Okay. Um, so you can have this, you're basically going to have this app registration so that you'll be able to lock a specific account to the actual, how should I say it, the application that's running. So what this is going to provide us is it's going to make dApp development really easy for people. They'll be able to just drop in with React Native, and they're not going to have all this other crap to deal with, or MetaMask or any of those things. You're going to be able to just develop a native app directly with React, and it's going to kind of couple and handle all of the node stuff. So you'll be able to have the full trustlessness. You'll have the full security of a full node. And all these dApps, instead of it being a specific dApp browser, mobile dApps are just going to be their own standalone apps. But they can all share the same node, which is really cool. So if you have your Nexus wallet running, we're going to design it. That's the architecture we're leading to. And this would be a good time to get feedback from you guys too. But basically, we're going to have this type of, you're going to take an app, you register it, blah, blah, blah. And then we're going to probably lock it to that account where you're going to have to log in on your Nexus wallet right now, or we're going to create a different security precaution. So you can create a SIG chain and say this SIG chain can only be accessible through my Nexus wallet app. I don't want to give a third-party dApp developer access to it. We're going to eventually unsandbox that to a point, but you're generally going to have to log in on your Nexus app first, and then it's going to share that session connected, and it's going to register this other dApp so that when you open up the dApp, it's going to say on your Nexus wallet, this dApp would like to use your Nexus account. Do you agree? You say yes. So we're creating our own type of sandboxing environment. And that way the dApps are never going to manage credentials, right? This completely just eliminates any of those threats of somebody, even if it's open source, trying to create a backdoor app to try to steal login credentials. This is just going to be impossible to do because we're going to lock it into this Nexus wallet app. And then that makes it much easier for other developers too. So it's, if you've ever had those banking apps where you have a secondary app like card controls or something for Ally Bank, they say you need to log into the main Ally Bank app first. It's the same type of concept. So the Nexus wallet will be kind of the core of this whole developer framework that we're doing. So we've taken this as, as you know, we don't just do one thing for one thing. We do one thing that does as many things as possible, right? Kill 3 birds with 1 stone. So while we're developing this for the mobile app, we're also developing this framework on the side, or the beginning foundational steps of this framework that's going to make mobile app development a completely different landscape. So I just want to add those little details in there.
Yeah, and that gives some background as to why it's taking us longer to get this done than other mobile apps would. I mean, it's not just a simple thin client. We could have knocked that out pretty quickly, but getting the core running is on mobile devices is something else completely. We do have it running. I think the way we're having to do it is like a cut down version of Linux that we run, and then are we just using that to compile, or is that actually executing the daemon? I can't remember what Kendall was saying that he was doing.
I think he was using some extra like app that does command line stuff. I mean, it's all building native onto the OS X, so it's compiled native, but I think he required that compilation or something in order to integrate it, because the packaging, like we said, this hasn't really been done before. So you got to give massive props to Kendall. If you guys ever see him, he took this beast on and he did it, which is great. Yeah. We always say, like, at least my philosophy with programming is there's always a way. There are so many possibilities, right? When it comes to computers, that you always find a way. You just, if you give up before you do that, then that's where you experience quote unquote failure, right? But if you never give up, you always will find a way. And Kendall found a way, which is great, because this is kind of charting into new territory, and it's gonna make people see dApps differently, right? Like a dApp right now is like, okay, well, what do I go like on a web browser? I got this special thing. It's still like kind of geeky. Now people are gonna download dApps and they're not even gonna realize it's a dApp. It's, hey, this is just some awesome app that I use. Well, oh, did you know it uses blockchain? I mean, the word blockchain, at least by the way we're seeing, I think is going to become more minimized. It's going to be, Tau framework Nexus, rather than like, oh, the blockchain does everything. The blockchain is going to be kind of less known. We've abstracted everybody away from the blockchain, where you get the benefits of the blockchain, but it's just a really simple, easy to access point. So
yeah, as Colin just said, Kendall's done a great job so far, and he does have a node running on iOS. It connects to the network, synchronized to the network. That's all working. Right now, he's got it connected to a test seed node with client mode, with the light mode that we need it to be running. And right now he's having some issues with generating signatures, I think, or he's basically it's using the Argon 2 hatching function, which I think might be having some issues with memory bounds, but we're working through it. There's options for us to resolve that, but I think we're just trying to resolve that right now. But that seems to be the last big hiccup for us anyway. And as soon as that's done, then he can essentially hand that over to Key, or Key can hand his bits over to Kendall, whoever's going to do it, and they can literally just knit the two together, which is a fairly straightforward process. That, you know, the UI is kind of done. It just needs to be able to call all of the API and RPC methods that it needs to on the core. Once the core is running, it's a case of just knitting them together. It should be quite straightforward. So mobile's coming along very nicely, I think.
Yeah. I mean, the biggest hurdle was the if, is Apple going to prevent us from running a secondary process, right? We had a few different ways that we were going to tackle it, like executing a main method and stuff through React. But I mean, we got through that hump. Like, and that's what we were saying on the last one, is our hump is like getting iOS running. It's running. It's good. It's gold. So we have like a couple little implementation bugs, right? Because we developed client mode, but we didn't test client mode on mobile hardware yet. So now that we're running on the hardware and everything, we're realizing, I think it was an issue with Argon 2 hash function. That's pretty much the only snag we're at with the mobile. And then Christo's UI looks like it's done, like just about. So, I mean, it's pretty much like we got like this one last little piece, let's get this Argon 2 working. And then Kendall's like a couple deployment things that he had to add. But I think he's pretty much there from last week we were talking about. I think he's finished all that, hasn't he? Is Kendall on here actually?
Yeah, he's on the call. He might unmute.
Kendall, why don't you tell everybody what you've done, man? You want it?
Oh, there. Can you hear me?
Yeah. Put on the camera, man. People see it.
Well, I have it's my phone. So,
okay.
Yeah, it's not going to work. Wait, hold on. There you go. I have it on my charger, so.
What's up, Kendall?
Yeah, so everything, I mean, you guys kind of explained it already. But yeah, in terms of like packaging and all that stuff, right now I am running the Nexus core and my little like test UI in two separate apps. And so I'm having, basically I made a little, just a test, React Native test app where I can just type in, whatever. So that's what I've been using to interface with the Nexus core. So once we kind of figure out some of these bugs we're having with client and, generating some of this stuff, then all I need to do is basically, merge those two concepts together, which is a React Native, or I guess what I need to do is figure out how to do it. And then I can get Key involved and we can kind of just wrap it up. But yeah, obviously I'm sure everyone's like chomping at the bit to get a hold of this. And it seems like, we're taking forever, but like, I'm actually kind of impressed how far we've gotten. Cause only a couple months ago, I was like, I don't know. So we've made big strides. So I understand it's hard to be patient, but it's going to be dope. So just hold on just a little bit more, but we got it. We got you.
Thanks, Kendall. Well, as you say, I think we're going to end up with something that nobody else has done. So that's going to be
it's not only just that, but it changes the whole landscape for dApp developers too right now. I mean, you have massive deployment headaches. I mean, they had a dApp browser, I think, in one of the Ethereum wallets, and it got removed from the iStore because they don't want you to have, right? So there's all these hurdles that all these dApp developers are dealing with right now, let alone all the fees with Ethereum and everything. Now, building this nice framework like Kendall having to put together, it's going to be really powerful for any developer, because we're basically going to be simplifying and abstracting the developer into just this nice little React sandbox, so that just a React coder can develop these native apps. And it's going to be a simple one-click go type situation. So I think we'll be seeing a lot more. Like, think of the module, kind of, it's like a module for iOS, basically. So we're building a module as a standalone app framework. So it's the same module, you know, logical layer interface framework, because the Tau framework extends all the way up the stack. So Kendall and Key have been working on the logical and interface layers mainly, but it's basically all of that packaged for so that you get all these really, really positive benefits, and it's going to be standalone dApps. You have no custodial issues. You have completely trustless. You have redundancy. Like, here's an example. If, let's say I'm using my BitPay app, and then somebody decides to just DOS the BitPay server. Well, everybody, you know, that has the BitPay app can't refresh. They can't update, right?
Yeah.
It won't work. It's done. It's done, right? There's no redundancy. So it's kind of like, it's kind of silly, for at least in our perspective anyway, to like build this entire decentralized framework and, you know, network, and then just like make a centralized mobile wallet, because, you know, it will fail eventually, especially, you know, I mean, servers go down, hard drives get corrupted. I mean, things happen.
I mean, we get DDoSed every day. So
yeah, oh yeah, every day. Like, my nodes 24/7, man. Like, they're banning someone at least once every 5 minutes. Like, I mean, they just DOS. I mean, back in January, they were DOSing, they were doing denial of service, and then they found a bug and they were attacking that to stall the network, and they were hitting us from every possible angle they could. But like,
I
mean,
don't know.
Held up pretty well, man, considering.
Yeah, I don't know what it is with New Year, but that's when the DDoS servers start kicking in high gear.
They try it because I think they think that we're going to be getting fucked up or whatever. I don't know, like getting drunk or whatever. Like, I mean, I quit drinking like a year and a half ago or whatever, you know? So yeah, it's just like, yeah. So for any guys, like, I don't drink. So, you know,
Right.
it's just trying to find a better day to attack us or whatever. I don't know. But yeah, but so with this mobile wallet, right? If like somebody's node gets DOSed, right? Let's say the test server, boom, you just find another connection, right? Because you can talk to every node. It's actually talking over the Tritium protocol and everything. And it's managing all of the states like the Tritium protocol is, but instead of a global state where it has to have every single transaction, it's just a local state. So you just have your SigChain transactions, and then block headers, right? Which are about 200 bytes, 300 bytes per header, right? And we just do Merkle path verification. So even if you want to look up something like a name, right? That was pretty cool to actually add in there when you could do a name lookup, because name lookups are outside of the scope of your SigChain. We created this cool little triggering system with the LLP where the API will go out and then it'll send a trigger or a request out to the Tritium LLP and the network and say, hey, we need to, you know, ensure that blah, blah, blah. You know, that, you know, this specific name is resolved or whatever. And so you'll send that out, and then you'll receive a Merkle transaction back, but the API will wait until the Tritium LLP actually grabs that data and then send it back to you. So that was actually a really cool, I mean, technology that kind of formed from the requirements that we had. So, I mean, you can in client mode, I mean, we have it sandboxed a little bit where it just won't let you download everybody else's stuff just for privacy issues. You also have to log in too. So if I'm going to subscribe to notifications for my SigChain, I have to be the one that's actually logged in. I have to be, you know, making cryptographic proofs in order to verify that I am me. So somebody can't just go DOS somebody's SigChain or try to like subscribe. Like, I can't just go in client mode and say, hey, I want to listen to Kendall's SigChain. Like, the other nodes are going to reject your connection request. Right. Because it's not actually authenticated. So we're doing, this is kind of a how should I say, it's like a layer 4, layer 5 Lisp on the OSI. We're not doing the actual overlay yet, as far as that's layer 3 on the IP layer. So we're not actually packet snipping and like doing the wrapping and the, you know, decap and end capping. We're kind of putting it up on the higher. So we still are doing TCP connections, right? But we have this authentication system where we're now actually starting to see by Genesis rather than by IP address. And that's, Paul can get into the P2P API and how he designed that too, which kind of ties into that a little bit more. So, I mean, the concepts of Lisp are here, and we're working on an RTR, which is a reverse tunneling router right now for NAT traversal, right? So you're going to basically be able to enable on your node, hey, I want to enable this node as an RTR. If you have a publicly accessible IP address, you're not behind a NAT, then you can be an RTR, and it'll just be advertised just like any other peer. And essentially that allows you to kind of punch holes in that. So we're going to be able to start doing that for more NAT traversal rather than using UPnP and NAT PNP, which we're assessing right now, and PCP, I think, are the other ones. So we get a little bit higher NAT traversal, you know. So yeah, it's really cool how it's all kind of coming together and really, really beautiful. So yeah, well, that's just the nerd in me, I guess.
Yeah,
I was,
sorry, Kendall, go ahead.
I was just like, what was it, last week or 2 weeks ago? I fired it up and I was like, Paul, do you see me? And he's like, I see you, you're connected. I was like, yes. So it's been quite an adventure, but it's been really amazing about, you know, what we've accomplished so far. So
yeah.
We're almost there. Be patient, and then, you know, we'll obviously we'll have a beta, and we'll get people involved. But
it's much sooner than Tritium soon too. So it's
yeah, exactly.
Soon this time.
yeah.
We've talked about client mode before, I know, but I just want to reiterate that with client mode, it is not downloading full blockchain because it doesn't need to know about everything. Only your SIG chain transactions and the block headers for the entire chain. And that means that right now, at least, the entire blockchain that it needs to download is about 240 megabytes, I think, compared to the, whatever it is, 8, 10, 12 gig that a full node is. So your synchronization time from block 0 to fully synced is however long your node takes to download 240, 250 meg of data, which on 100 megabit connections, you know, whatever, 20 seconds, 30 seconds or something. So you can sync from 0 to fully synced in under 30 seconds. That's frighteningly fast.
Yeah, and it's also really cool too, because we're deploying all of this in a bit of a suite. So like this next hard fork, right? The client mode is going to come out on the next major update, which is with pooled staking and the LLD updates and stuff like that. But it's kind of this really cool suite of everything kind of put together, because we're going to make it by default when you fire up. I mean, I've seen support requests saying, hey, I don't have 10 gigabytes spare on my hard drive. And it's funny. So people don't have hard drive space. It's kind of strange, but anyway, but this is by default when you fire it up, we're going to have to resync anyway, right? Because it's a database upgrade. So you can either rebootstrap or resync, but it's going to by default load up in client mode, even on your desktop wallet, right? So you'll fire up your wallet if you're a first time user, and 20, 30 seconds later, boom, you're ready to use it. You can send transactions, you can receive, you can log in, you can do all of that stuff. So it's going to be a really quick setup, and that'll be something that will be by default. Most people, you know, that are just holding Nexus and turning their wallet on every once in a while can just use client mode if they want to conserve some disk space. I mean, it uses like 20 or 10 megabytes of RAM or something like that. I mean, it's like nothing. It just takes nothing to run. So yeah, that will, I think, really help new users, especially, you know, like the syncing process is cumbersome. And so the syncing or full node is going to be kind of a more advanced user. You know, if you're staking, you're going to have a full node, right? If you're running a seed node, full node. And I mean, people will still run full nodes, and that's, you know, the Nexus proof of stake. One reason why we created the trust system, why it is because that also is an incentive for your node to be online all the time, right? So we get a lot higher uptime for all the nodes because you have to have your node online to be getting that stake. So that kind of creates a more robust game theory, because we've noticed with Bitcoin, there's a really big node incentive issue. People just have no incentive to run full nodes, right? And that's why we've seen it kind of like, I mean, and the cost to run a full node is just ridiculously high too. So yeah, it's going to be really cool to see, you know, like I'm excited to just like see what people's reactions are, where you just fire up your wallet and it's like, wait, it synced? It's like, what is this blasphemy? Like, what is this sorcery? This, you know, it's fun. Like, yeah.
I know the number of times we've said to people, oh, well, you know, you might need to reset your database and, you know, you can download the bootstrap again. We'll just be able to say, hey, you know, just wipe it, resync. It'll take 30 seconds.
Yeah,
and you know, we'll add that as an option in the menu. I think in the desktop wallet. Just
yeah,
wipe the database and resync.
I guess we're kind of, while we're on that topic, I'll give a little update on what I've been working on, and then you can just take it from here, Paul. I've been deep in the LLL. the last few months. As you guys know, I started some scaling tests in March, and those scaling tests have driven me to find a lot of ways to optimize it, and I've finally settled on the LOD. So last time I said the LOD is looking very promising to be fully constant time and yada, yada, yada. It kind of was. I mean, it would be constant time for a while till you get to like 100 million keys, but after that, like you'd start to still see performance degrade. So I actually have finalized the architecture now, where it actually is fully constant time. So I testing, and depending on your probability, it's super tunable, but at about 1,000 hash map files, you'll end up only having to do 2 to 3 disk seeks to find the key, right? Now, in like a, let's say, in a normal conventional database, like let's say you have 1 million keys, in a binary search tree, like which is what most databases are, it's going to be like 15 to 17 iterations, 15 to 17 disk seeks for 1 million keys, right? Us with 1 million keys, it's 2, right? Once you start getting to maybe 3 disk seeks, we're talking billions of keys. Okay, so I've created like these multiple layers of bloom filters. So you have this like row level bloom filter, which basically checks the entire bucket, and that's your primary bloom filter. What I found is that bloom filters worked great, but once they started filling up, the false probability and the false positive rate just started really killing me. And eventually it would just kind of like, it would degrade in performance. And so it just wasn't good enough for me. So this next architecture.
For everybody's benefit, Colin, can you just explain what a bloom filter is? Or rather, am I right in saying that it's basically just a way of saying with a reasonably high degree of probability, the thing you're looking for is here or not here with a reasonably high degree?
100% probability it is. If it says it is not there, it's not there, right?
Okay.
100% probability. But there's, you know, if it says it is there, it may not be there, right? So it's got a lot of false positives. So you have to tune them just right. And I've kind of implemented a different, like I said, the primary and secondary bloom filters, where I have an actual byte level bloom filter, which is actually pretty cool. I haven't ever seen it before, but I figured out how to take 1 byte and create a probability value of like 32,000. So on average, I get about a 5 or 6% false positive rate or duplication false positive rate of the bloom filters with 8 bits, right? But now the new secondary bloom filter, I made it so that you can just take a whole byte stream and then just select the number of bits you want per stream or per key. So that I found interesting enough, 7 hashes and 13 bits ends up being a false positive rate of 0.1%. So that's 1 in 1,000 that's going to have a false positive, right? Or a duplication. So when you have a duplication, what that means is you're going to end up having to read a file again. So every time you read a new file, just consider that a disk seek, right? Seeking to a binary position on your disk takes a lot of time. It's the slowest part of accesses, right? Because even if you think about a hard drive, you have that mechanical arm that has to actually physically move, right, to find that stream of bits. So it's very cumbersome. So you don't want to seek as much as possible. And so, so when you hit this and you get a false positive, then you're gonna have to read that file and then check the checksum to say, oh, is this the correct key that I'm looking for? And so over 1,000 hash map files, right? If you have like 1 in 100, then 1,000 hash map files, you're gonna have about 10 disk seeks, right? Required for that. Now, with this new byte level bloom filter, which is really cool because it's a single filter that's 13 bits. So you only have 1 key implemented in there. And then you do it with probabilities. So I say, like on the byte level, I say, well, there's 1 of 8 possible places this bit can go, 8, right? But then I say, okay, well, if I can put another bit in there, then that's times 8 again, and then times 8 again, and times 8 again. So when you get to 5 to 7, you get around 32, 33,000. And so it's a super, super compact way to use it too, because I could be setting the first bit 3 times for 3 hash functions because I could be colliding as the first bit. But those 3 collisions, right, I was going to say that maybe there's only 1 other bit here. So that number, right, that is stored with this filter becomes very, very unique and very difficult to get false positives. So at about 7 hashes and 13 bits per filter, actually I got it down to about 0.1, 0.2%, which is about 1 in 1,000. So, so you understand a hash map, whenever I have to add a new hash map file into the LOD, you're going to potentially add another disk seek, right? Because you have 1 more file that you have to potentially iterate through. And these files are kind of stacked like this to resolve the collisions. So getting that probability to 1 in 1,000, that means I can have 1,000 hash map files and I will never get a false positive, right? It will always tell me exactly where it is and what file it's in. So you first check your primary Bloom filter, which is the row level. So that's another nice, is when I'm checking if keys exist, I only have to check the primary Bloom filter first, right? Which most of the time is gonna rule that out. It checks about 600,000 records per second. So I can search the entire data set and check if a key exists in that data set about 600,000 times per second. And then the reads are about 200,000 reads per second, and the writes are about 120,000, right, per second. And this is no memory buffering, no memory, absolutely. This is straight to disk. There's nothing happening. It's just a forced write straight to disk. So,
Hey, Colin.
So, yeah.
Just to avoid any confusion, when you say key, you're not referring to a cryptographic key. You're referring to the key that's used to access the data on the disk.
Yep. So anyway, you have the primary Bloom filter and the secondary Bloom filter. So you check the primary, which means I only have to check one Bloom filter to check an entire set of hash map files. So it could be 1,000 hash map files. I only check one Bloom filter first. And then I check the byte level Bloom filter after that. So with the combination of all of these, right, I have basically 3 steps. You check your primary Bloom filter, you check your secondary Bloom filter, and then you check the actual hash map disk file to check that the key that's recorded in that hash map slot is the key that you're actually looking for. And then you do a read. So you have the first disk seek, which is for your index file. You seek to the position in your index file and read these filters out, right? And then the second disk seek is you seek into the actual hash map, but based on this design and these probability rates, you'll always get the right file. You're not going to have to sift through multiple files, because if you have 2 false positives or 3 false positives, your Bloom filter is going to tell you, well, there's 3 possible hash maps that this key might be in. So you're going to have to seek and seek and seek. But with this, with 1 in 1,000, you only have to do 1 seek on that hash map to get your data record. So when I got up, so it, right fresh database, it does about 180,000 reads per second. Once I start like really loading it up, like 100 million keys, 50 million keys, it's maybe like 140,000. So it slows down a little bit, but constant time doesn't mean it's the same thing forever. That just, it doesn't. Constant time is the average cycles are generally going to be the same amount of actual instructions on the CPU. So, and the disk. So, yeah, it's really come along pretty incredibly. Now, basically using this, let's say we're going to use a data set of 1,024 maximum hash maps, right? So I'm going to set the database to say I can only have 1,024 max hash map files. Let's say I make each hash map pretty big, like half a gigabyte, something like that. That's going to be 12 million keys. So do 12 million times 1,000. That ends up being 12 billion. So essentially, based on how it is now, it's super extensible, where if you want to be building a data set that's going to be having 50 to 100 billion keys, which just so you know, you're not, there's not enough hard drive space for that generally, right? Like a billion keys is a massive data set. Like 1 million keys is a huge data set. If you've ever used MySQL and you start noticing, like when you get to like 500,000 keys, that thing starts slow. That's only 500,000 keys. So just essentially, I feel very comfortable now. I mean, with the previous design and the lack of the Bloom filters, it would degrade in performance over time, but it's still really, really fast. But I mean, if we blew up next month, right, and people just started using Nexus and we have millions of transactions a day, Nexus will get slower, right? Because just the database wasn't fully constant time. But now, not a problem, which is really exciting for me, because I don't feel like I have that axe hanging over my head a little bit, where it's like, you know, I got to get the LOD more improved. It's got to get better. Like, we don't want it, you know, we don't want it to just, the data set to grow out of bounds. So, yeah, being able to operate with 1 billion keys, where if you go from 0 to 1 billion keys and you really lose about 40% of your performance, about even less than that. I mean, I have to test my new implemented production code to get those specific numbers. But I mean, it's pretty crazy. Like when I was running Berkeley database, right? Just testing that neck to neck with the LLD, By the time I got Berkeley DB to about 10 million keys, initially the first, it would be like 70, 80, 90,000 reads per second, maybe a little faster. I mean, when I got to 10 million keys, it was like 2,000 per second, 1,000 per second. I mean, just ridiculously slow. I mean, you just lose orders of magnitude speed and processing capabilities. So I've only been aware of one other constant time database that was actually built into the original Unix kernels, and they used a form called extensible hashing, which is somewhat cool, but this is kind of a nice blend of beautiful different, architectures and the way to use them too, with like the byte level Bloom filters as secondary filters so that you don't get saturation of the keys, which creates false positives and all that. I mean, it's just, it's like a symphony of informational processing to me anyway. It's very beautiful the way it all flows together. And this is going to be a huge shift in the processing capability too, because your database layer is one of your biggest bottlenecks. So, my last tests were like 30 to 100,000. I think I'll probably exceed that once I get this whole new LLD plugged in. And then you're syncing too. When you're syncing from the network from scratch, one of the biggest bottlenecks, actually, believe it or not, is checking if keys exist. Because I have to check if an input was spent, right? And that's just done with a key. It's a key stored in the keychain, right? So in order to do that, I have to search through all these hash maps if I don't have these Bloom filters. So now that we got key checking up to 600,000, I'd say right now it's probably like, especially with 13 hash maps, maybe 80,000, right? So we're basically multiplying our capacity by about 6 as far as like checking proofs, right? Which is a huge cumbersome process. It's a little clunky because there's not really many good ways to say, without knowing the entire data set and everything in the data set, how do I know if something's in it without having to search through all of it, right? And we've gotten it pretty well tuned down, but this, I'm really excited to see it plugged in when I actually sync with it. I have a stack of hard drives or SSD on my desk because they're just like been fried. I just keep burning them out over and over again. So it's been worth it, but I feel very comfortable with it. Last time I was talking, I said, it seems like we've reached constant time. It looks like it's constant time. I'm really, I think we're finally getting to constant time, but I wasn't entirely sure because I didn't have enough test data. And I was also just really excited. I'm like, oh my gosh, it doesn't slow down. So now I feel very comfortable with the architecture and the implementation and everything. And the data is very, very good. It's highly effective. And I found many different bottlenecks in that. So this is going to make everything faster, everything much faster. So if you didn't think Nexus is getting faster, it's going to get way faster from here. Especially in our smart contract processing, which is perfectly timed too, because I have a feeling after this update, maybe later this year, or earlier next year, we're going to start to see a lot more growth in Nexus. So this has been something I've wanted to get done before that, to make sure that we don't end up having, people don't end up, seeing Nexus any less than what it is, right? We don't want it to just get really big and then all of a sudden it's like, oh, my wallet takes 2 seconds to load, not less than a second. We'll be like, oh, okay, well, I'm going to fix that. Now I feel comfortable. Like it could grow. We could grow bigger than Ethereum and it's not going to slow down. So I'm very happy about that because now I feel like our foundation, which this is like a huge foundational element, is really just set. It's working exactly as we need. And it's really sustainable. And you guys will also like this too. My last sync test, because I added linear probing and all this other stuff too. Sorry, I added linear probing with the Bloom filters, but I'll spare you guys the details on that. But that makes it faster too. But adding linear probing, I actually dropped my blockchain size from 11 gigabytes to 8 gigabytes. So we took 3 gigabytes off of the blockchain size too, with this database update. So it's got a lot of good stuff under the hood. It's well worth the update. And I think this is probably going to be our last major LLD overhaul. I haven't done anything this deep on the LLD since 2018. I think November 2018 is when I got the current, binary hash map and everything put together. that is running in the production environment right now. So it's been a couple years, and that's good too, because I wanted to just make sure everything was solid. If anybody isn't aware, the low-level database has been running in the production, powering the entire Nexus network since 2016. So we've got 4 years of production value testing and operating on it, and we've got 2 years on the current binary hash map architecture, and then this new architecture is really not. It's not a huge change in like the actual way information is processed. It's just got all these extra components in there that just make it a lot smoother for the entire system. So that is my update.
Sweet, thanks.
Yeah.
Was this? We got Scott here. I'm hoping he can give us a bit of an update on pooled staking. I know I gave a brief update earlier, but it'd be good to know exactly where it's at and how the testing's going.
Yeah, I got my internet fixed so I can put my video on. I was getting really poor reception when he started, and I kept giving me warnings about bandwidth. So I kept the video off at the beginning.
So
I
what's
think
been
that's
going on?
all
Where are
good
you at?
now. Before I start, let me just point out, with what Colin was just saying, and he's talked about this before, if we're going to have performance, it has to start from the bottom up. Those bottom tiers have to be incredibly fast so we can build the performance on top of it. They don't become a bottleneck. But I can just give you an example of he's talking about performance degrading after billions of keys. I actually did a real live project where we had a 4 million record database. Now it was a relational database, so it's a completely different structure. But if you wrote queries to that database and you didn't write them exactly right because of the size, your 30-second query could take 30 hours to run. It was very sensitive to how you wrote things. And that was with 4 million records of data. So you can kind of, maybe that helps put it in perspective what it means to be able to perform at 1 billion keys, even though it's a different data structure. So anyway, as far as pooled staking goes, I think in the last call, we kind of gave an overview of how we were designing the pooled staking itself to function. I can go into a little more detail now because we've worked a lot of that out. The pooled staking, since about the beginning of June, it's been code complete, and we're kind of moved into testing and working out, and like Paul mentioned earlier, some of the tuning details, and just in my case, just figuring out how to test some of the things that require a lot of input. Just to give you an idea what we ended up doing beyond just the pooled staking, because today we have the stake minter, and it works. It's basically a piece of mining software that's built into your wallet. It works kind of like the hash and prime mining, in that it's hashing blocks, and it's using the stake rules to do it and generate blocks that way. Pooled staking is a different animal. It has a pooled stake minter, which is kind of what I talked about the last time, how it was going to assemble things together. But there's a lot of other components to it that need to be built, because we're not mining pool blocks or proof of stake blocks just within your local environment, but we're combining together input from machines that could potentially be all over the world. So what we've gotten updated, in addition to finishing the development of the pooled stake minter, we updated the LLP, the networking, to be able to communicate the pooled staking information. The way it's going to work is each individual account, each individual user who is pool staking will create a coin stake. And excuse me, that phone call, shut it off. Will create a coin stake transaction just like it does today. And then these are submitted to the network and communicated over the network using the LLP protocol with new pooled staking messaging. Locally in your machine, when you receive this, there's a new stake pool, which works kind of like a mempool, but it's separate because it's not part of the blockchain. But it borrows some of the logic and adds a bunch of new things that are specific to pooled staking and how it's going to receive coin stakes from all over the network, how it's going to relay them. Then as your pooled stake minter builds the block, it will select a set of coin stakes from the stake pool. And it's a selection mechanism that's random, but it's weighted. So it's going to favor selecting other coin stakes with higher balance and also with higher block age. So one of the things we wanted to do was write this in such a way that it could handle pool staking if there's a few hundred nodes on the network or a few 100,000. So it's going to favor the higher balance nodes for you to include in the block that your local wallet's assembling, but it's also going to include, it's also going to favor higher block age. And that's one of the ways that it helps avoid people getting kind of stuck, that they're not receiving a pool block and they exceed the 72 hours and their trust starts decaying. So as they go longer and longer in time, other nodes are going to give more weight to their coin stake for including it in a block. The other thing your local wallet does is, as your block age grows, it's allowed to include more coin stakes from other nodes. So it'll be building larger and larger pool stake blocks. So it's over time, it becomes more likely that you're going to find a block, and it's also going to become more likely that other people find a block. And that way, everybody who's pool staking should be able to fairly, find blocks within 72 hours as long as their node is up and running. To make all this work, to be able to combine together 5 or 10 or 20 coin stakes that are produced by other nodes, the way that the blockchain works now, if for those of you who are familiar with it, and for those of you who aren't, there's a special transaction. It's called a Coinbase for hash mining or prime mining, and it's called a coin stake for proof of stake mining. And this is the transaction that rewards the miner. Okay, for a hash mining, the miners get paid. Well, there's a transaction included in every block that contains their payment, and that's called Coinbase. And we have a similar thing for proof of stake, which rewards you with additional trust and your stake reward. That's called a coin stake. Well, in order to combine together 5 or 10 or 20 of these, we now have to change the block structure to say that the block can have not just one coin stake, and it still will only be allowed to have one Coinbase. But if it's pooled staking, it's allowed to have up to a certain number. And that number, like I said, grows based on your block age. It starts out at 20 and then it bumps up over time. And so when we go to the next version, when we activate, we will actually be changing the block structure in order to support pooled staking. So all of this is what's come together now. It's code complete. I don't know how many people are in Slack or in Telegram. I think most of you are. I posted the first block, the transactions. It was a genesis and a trust that I was able to combine together to produce a pooled stake block. And so now we've basically proven that all of this works. Now we just got to test out all the details and tune it so we get the settings exactly the way that we want. Are we good, Paul? Did I miss anything?
No, I think that's it. When's it going to be done? I'm kidding.
I did miss something. Yeah. First to answer your question, the difficult part is trying to develop tests where I can run 20 separate wallets on my machine so I can be producing all this. It was easy to do two because I can connect my desktop and my laptop and run one wallet on each. Now I gotta use one of a couple different mechanisms to be able to run a bunch of wallets on my machine and produce 50, and then make sure the selection mechanism is working properly and some of these other things, and that it's still able to produce these blocks.
We can do a public testnet too, when you feel like we've completed all of the local testing cycles.
Yes, we can. The difficulty will be we have to push the difficulty up high enough that it doesn't generate stake blocks in like 2 seconds.
We start with an initial difficulty. So we'll probably be doing a public testnet, I think, on this, since there's a lot of new changes on this, and this is a completely new revision to staking protocol. I think we definitely would want to do some public testnet on this. So you guys will get an idea, and that will really be able to iron out all of these things. So put a little mental note if you guys want to be involved on that. Just kind of start creating a beta list and stuff like that. But we definitely want at least 50 to 100 people, if possible. Everybody pool staking. So I think that'll be a really good final test. So you guys, if you're wondering when it's going to be done, you'll see these steps being taken, right? That will give you more indication that it's getting sooner, right? Like when we're in public testnet mode, I mean, the implementation's done, right? Architecture is done, implementation's done,
Right.
testing phases. We're in the local developer testing phases where we're testing with our own networks. And then we're going to go to the public testing phase. And then after public testing phase, we're going to be releasing pretty much. You know, I mean, I don't know how long after. It really just depends on the polishing. But you guys remember Tritium. Just kind of follow that same type of guideline of how we release Tritium. This is the first Tritium Plus upgrade. So we'll definitely be needing to do more public testing.
That was the one thing I forgot, and that is the implementation right now is for full node only, not for client node. Not yet.
Supporting client mode. Well, we might not ever. I mean, maybe, but see, the problem is you require trust,
right?
Because if I don't have the transaction history, I can't verify that the transactions are not double spends, right? And I need the entire transaction set. So including those and creating my proof creates. I mean, there has to be some form of trust. So I haven't thought of a really nice trustless way to do that fully yet. We can do it with a little bit of trust, which the worst case, if you have a malicious node, is you're just going to end up, possibly staking for a block that will get rejected, or, they may be trying to like attack. And so they'll be spawning up. But I mean, we can prevent against that, protect against that by, having a large data set that the node talks to, all these different people and finding conflicting pools or whatever else like that. So, I mean, we can work around that, and we're going to make it as trustless as possible with the pooled staking on that. So that's why it's not implemented in client mode yet. You got to get the foundational elements first. Client mode's kind of like, the fancy dress, or, it's like, it's not the core of everything. It's just like, it's a result of the architecture. And that's what made client mode so easy to just drop in and create, is because the way the architecture works, where a SIG chain is self-contained and your register pre-states and everything are handled, and with the Merkle verification, it just dropped in there really nice architecturally. And the same thing with pooled staking. We want to get that foundation set, and then we'll get to the pooled staking on the mobile. But I mean, there is a potential issue because Apple likes to remove apps that allow mining or any form of mining. They'll probably consider staking a form of mining. So we're still a little bit, we're not completely sure if we're going to support pooled staking on the mobile wallet. I mean, you'll definitely be able to have your wallet running at home staking. You can keep that running all the time at home staking, and you'll be able to use the wallet from your mobile app. So it's not going to prevent you from using it, right? But as far as the mobile device doing the staking, that's still tentative. Exactly if or how we will implement that.
I just wanted to make sure everyone is aware of that.
Yeah.
That's kind of I wrote it specifically that it doesn't hash in client mode, but that and with the knowing Apple's restrictions, but there's then there's all the security issues that you mentioned, and we don't need to go into all the details of those. But yeah, so just so everyone knows that when this goes live, right now it's full node only.
Sweet. Okay, thanks for that. All right. So moving down my list of things that we've been working on, something that's been requested for quite some time. We've finally implemented SSL across all of our servers. That would be the Tritium server, RPC, API, and the new P2P as well, which I'll come on to in just a minute. At the moment, so just for those who don't know, SSL is just a way of encrypting, securing connection between two different nodes in such a way that any data that goes from one to the other is encrypted before it goes. So that's really useful for, say, the API, which uses HTTP, so it's plain text data that goes across there, and so you really want to be using SSL so that data is encrypted in exactly the same way as when you go to a website and you go to HTTPS instead of just HTTP, you're going to a secure encrypted connection. So that's been on the list to do for a while, but that's now implemented. By default, Currently, SSL is not enabled by default, although we may choose to do that. One of the reasons we weren't going to is we didn't want to break the network by forcing people to use SSL. But the way SSL has been implemented across our servers is all of them will listen on a separate port for SSL. So we're kind of doubling the number of ports we use, but it means that connections can be made either on an unsecured route, which it currently does, or a node can choose to use SSL, excuse me, which is exactly how the web works. When you go to a website and choose to go to HTTPS, that almost always is has a web server listing on a separate port. What this means, though, is that there's going to be options in your configuration to turn on SSL on a per server basis, but there's also an option to require it. So it can be on, and that would mean, say, for example, if you turn it on for your Tritium server, the main peer-to-peer network, it will establish SSL connections where it can, but if there's a node that doesn't have SSL on, or maybe it's an older node that hasn't upgraded to the SSL enabled version, then it can still make a non-SSL connection. That's the sort of the lower security option, but you can choose to have SSL required, so that if the server you're trying to connect to doesn't actually have SSL on, it will just abandon that connection. And that's really important for things such as the API. You want to make sure that the server you're talking to actually does have SSL enabled and will use it. And also for the peer-to-peer communications, which I'm going to talk about in just a little bit, which is a new API that we've built to allow communication between nodes outside of the main Tritium network. So SSL is done. In the API, we now support the notifications processor in multi-user mode. So the notifications processor is something that runs in the background. Most people don't even know that it is running, but what it's doing is creating credits for any debits that come your way, or claiming any transfers that come your way, or voiding any transactions that have expired, and all these kinds of things. In the desktop wallet, it just runs in the background. You don't really know about it, but we never had support for that in multi-user mode, which is a really important feature needed for excuse me, for dApp developers who are running a server with lots of people logging into the same thing. So that's been done. And then we've got a couple of new API. Actually, I'll come back to that. Since we're talking about dApp developers, we may have mentioned in Slack that one use case that's being developed by an external organization, they are using a rapid web app development tool called Bubble. Bubble is kind of like Wix or Weebly or any of those other no-code web app development environments, but they've been using Bubble, and one of the things that Bubble does, it has the ability to it has, I think it's called an API connector, and you can then configure that API connector to talk to whatever API you want, and they're obviously connecting to the Nexus API. And since they went through the work to configure that connector, they have very kindly decided to turn that into a plugin within the Bubble organization, and it can be released so that other people can download it. So download it and then configure it and use it. So this is going to be a way for other web app developers to produce their own websites that are built using Bubble, and then integrating with a Nexus node. So and it is so easy to use. I've watched them go through the process of adding functionality, something like a login screen, and once you have this plugin, adding a login screen to a web app and having it actually communicate with the Nexus API to log in and handle errors and all those kinds of things, it's literally minutes or less. It's so quick to add functionality. and then to do things like create accounts and tokens and all the other things that our API exposes, doing this in a almost like a WYSIWYG kind of environment. So there's no code needed to get a web app built. It's quite exciting. It's very cool. So that's been developed. There's some documentation that's being worked on at the moment about how to use that plugin within Bubble, and also how to set up a Nexus node to be able to have the Bubble plugin communicate with it. That's just being finished off at the moment, and I think that that Bubble plugin can be released so we can get other people using it as well. So that's quite cool. And then as part of that project and a couple of other projects that are going on at the moment, we needed to write a couple of new APIs. The first of which is a crypto API. And what that API does is exposes some functions to allow you to manage your private and public keys that are that are stored within your signature chain. I should probably backtrack a little bit and say that when you create a new signature chain, we have this special register that gets created inside your signature chain called the crypto object register. And what that register does is it holds 9 slots for private keys, or public keys actually. The things that are stored in there are hashed public keys. And those keys can be used for things like, well, we use it for, say, the client mode in order to prove who you are when you're subscribing to another node. So let's say, for example, I want to say, hey, I'm logging into the system and this is who I am. I can sign a message using a private key, send that message across the network to somebody, and they are able to then verify the signature, but they're also able to then check that the public key that I've said is the one that I'm signing actually exists in my signature chain in that crypto object register. So it's a way of tying in a signature with an actual signature chain and proving that kind of ownership, proving who you are. So that's partly what the crypto API is there for, is to allow you to generate those public keys and private keys as well, and things like that. It also allows you to switch between different key signature functions. So I think the default at the moment is to use brain pool keys, and if you want to use the Falcon lattice-based keys instead of the brain pool elliptic curve keys, at the moment you can do that using your config file. Falcon being our post-quantum resistant key verification, signature verification scheme, and you can now do that via the crypto API as well. But the last thing it does, and probably the thing that's going to be used the most, is it exposes some functions to allow you to encrypt and decrypt data using a couple of methods actually. It's symmetric key encryption using AES-256, but what's really cool is it allows me to encrypt some data using any key that I choose out of those 9 that I set in the crypto object register, or I can choose to use a name that's unique to me or my application. So for example, I can encrypt some data and say, hey, put in my password, put in my PIN, and I want to encrypt this data using a key called Paul's key or something, and that will generate a key based on my signature chain username, password, PIN, and that particular name as well. So I can generate a private key, or generate a symmetric key, I should say, to encrypt some data that's just based on my login credentials and that one name. So you don't have to worry about managing complex key names and things like that to remember how you encrypted it. You know, what key you used to encrypt it. You just need to remember your signature chain credentials plus the name of that you use for that particular encryption. So that's one type of encryption that we offer. But the really cool one.
After you're done with your little spiel on the crypto, could I add? Do you want to keep going, or could I add in?
Yeah, I think that the thing that the really one cool feature of the encryption is the ability to generate what's called a shared key. So if I want to send some data over to Colin, but I don't want anyone else to know it, obviously I want to be able to encrypt it, but I only want Colin to be able to decrypt it, I can generate a shared key based on my credentials. So basically it's based on one of my private keys and a public key that Colin sends to me, and that generates a shared key which we then use to encrypt, and Colin can then generate the same shared key using his private key and my public key, so that only Colin and I can decrypt that data and nobody else can. So it's a way of doing public key encryption targeted to a particular person. Very cool. So that's kind of encryption.
I wanted to add that really quick. The importance of this, and one reason that we spent the time to do the crypto object register now, is the Tau framework is designed to use the blockchain as something to augment the framework, but we want it to be very valuable for many other different types of industries, not just cypherpunk specific ones. So if you've ever used any like encryption type software, right? Like let's say Keybase for an example, that's like an encrypted Slack, right? You have to make paper wallet backups, you have to back up keys, you have to have recoveries, like you have to have all this stuff, and if you delete the app, it's gone. If you lose your phone, you've lost all of your data. Like it's almost worse than losing your wallet. I mean, I wouldn't say it's worse, but it's like you have to have this wallet.dat file, you have to have these keys to manage your encryption. So this kind of shows like some of the power of the SIG chain, but it also is going to provide a lot of value to other applications that just want to utilize encryption for encrypting their files, or having this type of peer-to-peer exchange. So it's really important that we found, because it's going to make encryption available for everybody. Right now, it's still, I mean, SSL is about the only encryption that we use like as a standard. All the other stuff, it's, I mean, not everybody has their stuff encrypted, or not everybody uses encrypted software, things like that. This is just going to take it to a whole other level where the complexities of cryptography and the complexities of using encryption in your application are just gone now. Now it's just simple. Any regular web developer can securely use encryption systems, because we're handling all of this under the hood that gets rid of these complexities. If you notice, like Zoom, right, they had issues, so they actually bought Keybase. Interesting enough, and yeah, they're having issues because they're like, oh, Keybase is cryptographers, and like, I mean, cryptographic engineers, people that know how to use cryptography correctly, it's very rare to find, and so not many applications can really gain the power of encryption because it's just overcomplicated. It's too difficult to use. So this creates this type of insulating layer indirection where through your conventional just login system, you have this access to all of this encryption, this suite of encryption. I personally am really excited about it, because I think it's going to be amazing to see kind of what type of applications start to develop, because it's very, very powerful to be able to use, and it takes cryptography, which is no really big, scary, complex thing. It just makes it something that any developer can start to access.
Yeah, absolutely. In fact, I might share a screen, because I wanted to talk about the P2P API after, and I think I'll demo some of that. But since tell you what, I'll unmute before I start talking. Colin, can you enable screen sharing, please?
Somebody was talking, and so
okay.
Everybody, sorry. You need a screen share?
Yeah, if I can.
It's Al or AI.
I'll make sure that you don't unmute your mic, please. If you keep unmuting, we might have to boot you. So try to let other people speak. All right, let's see.
Screen sharing, yeah.
What do I do? So I have to allow you screen sharing?
Yeah, apparently. Host has disabled participant screen sharing.
Okay. I don't know. I didn't put that in at all. Security maybe? There we go. Got it.
Yeah, that's it. Thanks.
I'm going to, so everybody knows, I'm going to remove your ability to unmute yourself for right now until Paul finishes the demonstration. And we're going to, once we open it up for discussion, then I'll let you guys know.
All right, how's that? Can you see my screen?
Yep, we can see it.
Perfect, thanks. Okay, so just we were talking about the crypto API. I'm going to whiz down to this window down here. Here I chose to encrypt a piece of data. The data is hello. Obviously, I need my PIN. This is just a test environment. The name that I've given to my key in this to encrypt with is just some key. In order to encrypt the data, that's all I need to do. And when I run it, what it does is it generates me a giant long public key, because this is I'm using Falcon. Falcon public keys are quite big. And the encrypted data is here, right? So now we have a really simple way that people can use their signature chain. None of this is actually on chain, but they're just using their key management from their signature chain to encrypt any arbitrary data using some arbitrary name that they've decided. So that's all I did was crypto encrypt data. The name of the key I want to use is some key. It can be anything you want. That's my PIN, and that's the data, and it's generated me that. And then I can, then later on, I can decrypt that data using crypto decrypt data. It's basically exactly the same thing. If I just grab that and do data equals that, and hopefully then if I run that one, oh no, I encrypted it again. Hang on a second. Decrypt. Okay, so I'll just run that again, and sure enough, the data comes back as hello. So it's a really simple mechanism to allow people to use their signature chain. You have to be logged in to do this, but use their signature chain to do encryption and decryption. I'm not going to go through the other functions within here. I just wanted to show how easy that kind of is. The thing I did want to talk about, though, and I will demo, is the new peer-to-peer API, which was a requirement that came up a couple of times where for various use cases, actually, where they wanted to have various users running a DApp or a desktop application or a mobile application, whatever it was, but a DApp built on Nexus, where they wanted to be able to send either messages, so like a chat kind of message from one user to another, or messages containing file data or things like that, but they wanted to send this data from one user to another. And we recognized that there was a few different use cases that had contacted us about this and wanted to be able to do it, and that we could provide that functionality quite easily using the Nexus framework, and have this ability to establish a peer-to-peer connection, a direct connection between two nodes. What's crucial about this is that we want to be able to do it without user A or user B having any knowledge of where the other user is, what their IP address is, or anything like that. We just want them to be able to establish that peer-to-peer connection using essentially their username or their Genesis hash to contact the other person. So what we came up with was this this new peer-to-peer system where if user A wants to start a peer-to-peer communication session with user B, they can send a request out over the existing Tritium network. It's just a single small request, and it goes out and it filters its way around the entire of our existing network, essentially looking for the node where user B is logged in. And if it finds user B that is logged in, it will essentially store a notification in user B's session on their system, so they can see that, hey, user A is trying to contact you. And in that message that goes out over the network is the IP address of who user A is, so that user B can then say, hey, okay, yeah, I want to start talking to that person. I want to start accepting data from that person. I'll accept that connection. And then user B can then create a direct connection to user A. And from that point forward, the communication is just directly between those two nodes and doesn't use the rest of the network at all. And what this allows us to do is then start sending data from one to the other. And this may be a simple chat application or something like that, whatever it is you want to do. But those messages don't touch the rest of the network. It's completely off chain, so there's no bloating or anything like that. There's no additional overhead to the existing network for all that communication that's taking place. It's just between the two peers. So I'm just going to give you a quick example of what I might do here. If I do, okay, so we're looking in this window up here. And I think I should be logged in. Yeah, I'm logged in. On this one is user Paul. And the window that's right next to it here is a remote node. This is one of my test seed nodes. And I think I'm logged in there with a user viz. So I wanted to show you how kind of easy this peer-to-peer communication can be achieved just using our API. And hopefully that will show you how easily a DApp, such as a chat app or a file transfer app or something like that, could be built on top of this. So the first thing I'm going to do is send out a connection request. I think it's request connection. What we're going to do is say, hey, I want to request a connection, and I want that to be to username viz. And the other a little piece of information I need is this thing called an app ID. And the app ID is there so that, probably self-explanatory, if there's two different applications using this system, such as one might be a chat app, the other one might be a file transfer app or whatever it is, each of those applications can use a unique ID, so the messages are kind of separate and they're not overlapping each other. So I'll just call this, I don't know, my app. Let's do that. And let's send that out. And hopefully it's going to give me a success. Perfect. And if I go to the window on the right hand side, which is my remote node, and then I do PDP list requests. So it's been a little time since I used this. Oh, perfect. It's found its way to me. So what this is doing is now saying, hey, I've got this request. It's from this person. And these are the ports I can connect on, and this is the IP address I can connect on. So I'm going to go ahead and make that connection. So I'm going to go, hey, yeah, I want to accept that connection. So PDP accept connection, username. Well, actually, pretend I don't know the username, but I know the genesis. Equals that, and app ID was my app. And hopefully it's gone, yay, okay, we've made a connection. So now behind the scenes, we actually have this direct connection between these two nodes established. And I think I can do PDP list connections and show, hey, yeah, okay, so I'm connected to this person, and that is Viz, and that's the IP address of the remote node that I'm connected to. And if I do the same thing on the remote node, there you go, I've got a connection. All right, so we've established this direct connection. This is the boring bit that nobody really cares to know about. Let's actually send some messages between them. So PDP send message, app ID was my app. Who do I want to send it to? Viz. And what's my message? Hello world. And that's going to send a message all the way over here. And then I think if I do list connections again on this side, hopefully now it should say, hey, you message us one. And I can view that message with P2P pop message. So we use peak message and pop message to read incoming messages, which is a semantic standard you use to be able to look at data before it comes in. So messages come in and are put onto a first in, first out stack queue. So you can only ever read the oldest message that's in there. So pop then reads the message and removes it from queue. Pop message. What am I doing here? App ID is my app. My fucking spell. Username was Paul. I could use Paul, or I could use the Genesis ID here. It doesn't matter. And hopefully it's going to go. Hello, there you go. You had a message, hello world, and it was a timestamp. This is the timestamp that we received it. And that looks really straightforward, but what that's doing is just sending data between, it's two nodes, and that data can be anything you want. It can be, simple text. So we've got a command line chat application between two nodes, or you could build an application on top of this that's sending other data. It could be files, it could be, well, anything you want really. There is a limit on the amount of data you can put in one message. I'll have to check what it is. I think it's 2 megabytes, but you can always break down larger messages into
by max packet size.
Yeah, it is. It's max packet size.
Depending on like how much I'm doing scale testing, I think it's like 10 megabytes now. Yeah.
Yep. Yeah. So we can do that either both ways. I can send a message back. P2P send. Let's just use that. Send message. Username is Paul. Data is goodbye. And then equally, I can go to this side and pop my most recent message from there. And voila, goodbye. And then I can terminate my connection once I'm done with it. P2P, let's just use that one, terminate. Terminate connection. And we are done. And that's it. Communication is over. Seems pretty simple. It kind of is. The important bit in all of that was that in order to establish that connection, I didn't have to find out who the IP address of the remote node was. I just had to send out a connection request with the username Viz that I wanted to talk to, and it found its way all the way over to this node where Viz was logged in. And if Viz happens to be logged in on several nodes, then that message will find its way to all of the nodes that it's logged into, so that you can perhaps then choose which node you want to answer that request on. So, file transfer app you might have running on a desktop, whereas a chat app you might have running on your mobile, and it will find its way to both. So the only requirement for using this P2P API is that in order to have somebody connect to you and accept the connection to you, your IP address needs to be accessible publicly or via universal plug and play, or one of the other mechanisms that we're looking at using NAT PMP and PCP as well as alternatives to UPnP. But I have UPnP enabled at home right now. So what that means is when I start the Nexus node, even though my laptop is sat here behind a firewall, it'll open port 6326, which is what I'm using and this is using SSL as well. It will then open that port on my router so that when the remote node tries to connect to my IP address, it knows to route that through to my laptop. So that's really the only limitation of it right now, is that you either have to have a public IP address, or you have to have UPnP enabled on your router, or you need to set up the port forwarding yourself. That's a limitation currently, but Colin mentioned earlier that in future we will be either utilizing Lisp or our own version of a router and RTR. What does that stand for again?
That's my next thing that I'm working on after I finalize all this LOD stuff. I'm gonna write the RTR, and that's like a component of Lisp. So if anybody's unaware, we're creating our own implementation of locator identifier separation protocol. We ended up not using Dino's implementation because it was kind of glued to Debian, and so we couldn't really get it to run on native Windows. And it's running in Python too. So C++ is going to be a lot faster, and we can kind of tie it together in. With this crypto object registry, you actually have a special key called your Lisp key, and that's what's going to be used to be doing all these signing messages. So the RTR is a huge component. It stands for reverse tunneling router. And I've actually already started doing some of the development on that today with UDP hole punching and stuff like that. But basically, that's just think of that as a server that does have a publicly accessible IP address, and both people are going to make a connection to that server, but they're not necessarily running the connection through the server. They're just using the server because the server is only keeping track of the port that they're actually resolved to, so that this one will then be able to say, okay, well, I can send directly to them, because when you make that outgoing connection to the server, it opens up a hole in your NAT, which stands for Network Address Translator. And then once you have the port, right, the port tells you where that hole is, then anyone else can send into that pipe, right? So that's what we're going to be doing. The universal plug and play, NAT PNP, and PCP. Right now we only support universal plug and play, but NAT PNP is kind of like an evolution of that, and then PCP is an evolution on that, and then we have the RTR, right? So we're going to have basically 4 NAT traversal techniques that we're going to be utilizing, so that I would say with a very high probability, we're going to have at least 99% of the nodes that are going to be publicly accessible, right? But you don't open up any security vulnerabilities, because what's nice about the RTR is at any time, in order to keep that hole open, you have to constantly send packets through your router, through the net. So you have to constantly just send keep alive packets to this RTR. But that makes it really nice, because the NAT kind of acts like a firewall, if you think about it. You have this public IP address where all your traffic is coming to. But then if you have a computer here and a computer here, right? If you have somebody listening on port, let's say 9333 right here, what computer is it that's listening, right? And that's where you have this NAT traversal, because since multiple devices share the same IP address, because IP4 only supports 4.3 billion devices, the network address translator doesn't know where to send it, so it'll just drop the packets, right? But when this guy opens up a hole, right, that's going to resolve to a specific port that the RTR is going to keep track of, and then that will just tell the other peer, okay, well, you can send UDP packets through this port to this external IP address, and they'll route into this device, right? But what's cool is the NAT hole will close after a period of time. So this guy has to keep sending keep alive packets, right, in order to keep that hole open. So in order to basically make yourself inaccessible, right, we can use NATs to kind of help with that, where you just, okay, well, I'm now choosing to be inaccessible, so I'm going to stop sending these keep alive packets. And even if the RTR still has an active mapping or a port mapping, the packet's just going to get dropped at the NAT after that. So it kind of gives you the ability to control your firewall on a more dynamic way, but it's not a firewall, so just don't take that incorrectly. It acts like a firewall, right? It kind of, the firewall's function is basically blocking inbound, mainly inbound connection requests, but some firewalls I've seen actually block outbound if they're not to a specific registered node. So the RTR is a really important component, and that's part of where we're, you know, like we're doing multiple things with one thing. So we need this RTR for the P2B API, but I'm also designing the RTR. It's not going to be an overlay RTR, right? So it's not going to be re-encapsulating the packets, right? Like Lisp does, because Lisp, you're going to basically strip off the Lisp or the IP4 header and then put on another IP4 header. And that's how an RTR works with Dino's implementation on Lisp. This for right now is just going to be handling and resolving so that you can send UDP packets directly through. But then when we get to the Lisp implementation, most of it's done already, because all we just have to do is add PCAP, right, which stands for packet capture, and packet capturing in there so that you capture the packets, and then you just encap, which stands for encapsulate, and decap, which stands for decapsulate. So an overlay is really just, you're taking a packet and you're wrapping the packet in another packet. And that's all Lisp is doing, is you have this special Lisp IP address that's your EID, and it's wrapped in an IP version 4 packet, right? So you're transporting it like it's a normal connection, but then the overlay has this extra piece of data that once you get to the RTR or the XTR, it's going to decapsulate that Lisp header and then give you that specific information for it. So it's pretty cool, because I don't know, we had the requirements, right, Paul? Yeah, and then, I mean, when you look out there too, like, The only thing I've found that is remotely close to this is called Matrix. The Riot, if you guys have ever seen Riot Chat, it's a decentralized encrypted chat app that uses like the Matrix protocol, which Matrix is pretty cool. I mean, I haven't dove too deeply into the technicals on it, but I mean, that's the only library I've seen out there that actually handles decentralized peer-to-peer messaging. Like there's only one framework out there, period, that does it. So, I mean, I personally think having that as your exclusive use, I don't think you're going to get enough people. There's not enough people interested in peer-to-peer messaging for that to really become like a huge framework. But adding this as a component of our framework, I mean, like Paul said, you can send messages between people. You can, now this is not just person to person, this is also app to app, right? So now start thinking about Nexus OS and, okay, well, you know, I mean, I was just thinking about the other day, okay, like when I need to send Bitcoin, I need to first go to my phone, I get my Bitcoin address, I got to copy that address, I got to paste that to myself in Slack, then I got to go to my desktop on my other Slack where I'm logged in Bittrex, and then I have to go, and then I have to click withdrawal, and then I have to this, and I have to do that every single time, right? Because I don't have an effective way to communicate from my phone to my laptop. Even though they're both Apple, I could kind of airdrop, but it doesn't really work. And the airdropping I've tried, it's just like, oh, sorry, it doesn't work, right? This is going to really open up a lot of that, where I think just by giving, I should be able to just see my phone and just send it to my phone, or create a connection request and say, hey, you know, do you need this file? And I'll be like, yes, I need this file, you know, and done. So the P2P API will work on local networks, will work between devices, but it also gives you as a dApp developer the ability to just communicate freely. So, I mean, in every one of these dApps is probably going to become kind of a standard to have peer-to-peer messaging, like for the dApps, right? I mean, it's just going to be standard. And what's nice about you being able to send to somebody by their Genesis ID, if I want to send some funds to Paul and it's a large amount, a large sum, you know, I want to make sure Paul's there to receive it and to see it. So I'm going to say, okay, well, Paul, hey, you know, are you there? And I can send it right to him, and that'll know, boom, it's right in his wallet. But I also know 100% certainty that that is actually Paul, right? That is a huge, huge thing, because on the internet right now, nobody knows who anybody is. Even if you have somebody's IP address, that still does not guarantee that that's the actual person that you're talking to. It just has no guarantees on that. So now we have secure is not only encrypted in peer-to-peer, like what, you know, other decentralized, you know, or, you know, signals or whatever do. This is actually fully authenticated. Nobody can spoof anybody else. You'd have to basically be in control of their sig chain in order to do that, right? So that just totally changes the landscape of how we're going to be seeing these things. Like the days of, do I, you know, are you this person? Oh, you might be a scammer. Spoof my email address. I mean, like, it's just, it's a mess. Now this is just, it's going to remove that. It's just, Paul, I know I'm talking to you. I don't have to send you test questions or something, because sometimes we've had to do that before, even on Slack. If we're going to send something securely, I'll be like, okay, Paul, is this you? You know, what's this question? Or, you know, guarantee this, or I'll send you this password for this encrypted private note. I'll encrypt it again over here, like when I was sending you the keys, right? It's just, it's very difficult and cumbersome, and it's a bit of a mess. So, I mean, it's really cool. I mean, because as this started to, how should I say, as this started to really kind of unfold, it just really kind of brought to light to me, like this framework is way more than just a blockchain. It's way more than just, I can build a dApp, right? It's a powerful framework that's going to change the entire landscape of the web and how we see the web and what people are going to accept, right, as kind of the common bar, right? Right now, it's just pretty common to say, okay, well, people are going to, you know, pretend to be somebody else. You got to watch out for scammers. You got to do this. You've got privacy issues. You know, somebody can spoof my IP address. I can DOS. Like all these problems we're hoping to start to see go away. And that regular developers. Well, this is another thing: is this framework isn't targeting just dApp developers. This is a powerful framework for any type of developer. Right? If you're a developer that's developing just a regular app, you're going to use Nexus because it does really powerful things for you that you're going to have to implement yourself. Writing decentralized peer-to-peer messaging, or even just the ability to send messages between people, is not the easiest task. And it's just, this is just, I mean, I can't emphasize it enough that like, this is one thing that really is building the power of this. Is we're not targeting one specific industry. We're targeting the entire internet. We're creating something that's valuable across the board for so many different types of participants that it would be silly not to use it.
Yeah, yeah, you made the key point there that even though that P2P messaging, establishing that connection seemed quite straightforward, that we are behind the scenes signing a message to say, hey, this is who I am, and the recipient can then look into their signature chain, check the public key that's in their crypto object register, compare that to what comes out of the signature verification, and provably know that it is the person they think they're saying it is. And then you add a digital identity into their signature chain, and suddenly you know without any shadow of a doubt who you're talking to, and you can see their digital identity online and so on and so forth. So it's really quite powerful. I know I was thinking, something like if you, what's the app we use? Signal, right? So something like Signal, which is an encrypted chat type thing. If you wanted to build an app like that, you could do that on top of Nexus without really even knowing that you're using blockchain, really even caring that you're using blockchain, without even using the Nexus token or anything like that. You can just have your app create signature chains for your user accounts, and they're stuck on the blockchain, and then establish those peer-to-peer communications to build your chat app. And you as an application developer don't have to know anything about how Nexus blockchain works or blockchain in general. You don't really need to care about that. We've lowered the barrier to entry for building these types of application. And then you throw in the bubble plugin that we're doing, and you can do this stuff in a website, in a web app, so quickly and so easily. It's very cool. And on that, I know people have asked several times if we would have a chat app in the desktop application, or even in the mobile wallet. I'd really like to see the developer community build a module for the desktop app, at least that start there. Yes, we could build one, but right now we're focusing on actually building the mobile app. So if we want to have a chat app within the desktop wallet, for now at least, that's going to have to be down to the developer community to build one. And I don't think it would be that hard. So let's hope somebody picks that up.
Yeah, it's really cool. I mean, more these APIs are just starting to really materialize. Like I said, I mean, Nexus is kind of like bamboo, where at first it's you can a lot's going on, but you can't see it necessarily what's happening, and that's been the last. I mean, you could say since the inception. I mean, there's the visible progress has really been elucidated last year, which is years and years worth of designing and implementing and everything. So now everything's really starting to pick up, which is really cool because all these prerequisite architectural components and foundational elements are in, and one complements another that complements another, and the architecture, it seamlessly flows together, which is nice. I'm sure you I don't know, I mean, I shouldn't speak for you, but like when I start implementing stuff like that, or I got into like client mode, it's just like, oh my gosh, this is so sexy. Like, I mean, you design something initially and you think about all these aspects of it, but like when you start getting down to using it and seeing, it's really beautiful how it all flows together, which has just been decreasing the actual developer cycles that we've been needing too. Features are a lot quicker to roll out now, comparatively. Now that's not going to be true for everything, right? I mean, but in these specific features, it's just, yeah, we've been wanting to do this for a while, and we've had a lot of people say, hey, can you make, an encrypted peer-to-peer module and stuff like that? And well, we just decided to make an API. So anyway.
So I think that's everything that we've been working on so far. I know what I'm moving on to next, which is I think I'm going to be working on a file API, which this will be for things like allowing you to store files. For now, those files will be stored locally, either in the local Nexus database or a local file system or network file system, with metadata for that file stored in your signature chain. in a register, and then some API methods to allow you to transfer those files to other people, or possibly copy them. I haven't even thought about that right now. But where this is leading is I think it'll probably be Armin or even into Obsidian when we have the when we have a distributed LLD. Is that the best way to describe it?
The LLD file. Really what the LLD file system does, it's not incredibly difficult to create a distributed file system with distributed hash tables and stuff like that. The difficulty is the gamification, the incentives of that. And from the best of my knowledge, I haven't seen a lot of successful implementations. I know Filecoin promised that. And that was what the IPFS guys did. And I think a lot of the reason that they've ran into hurdles is they've just been looking at it the wrong way. And based on how we're seeing it, we believe that we have a good formula for that. But it's essentially allowing you to monetize your hard drive space. So I noticed, the Digital Future was calling it the Nexus Cloud, and that sounds pretty catchy too. So just think of it as like a cloud, right? But instead of the cloud being a client-server cloud, it's just a decentralized cloud. So instead of you paying a big corporation to host files, and make you more money and have whatever else, you're paying your peer, right? It could very well be your neighbor, and you'll be able to select. If you have like sensitive files, I could be like, hey, Paul, can I pay a couple Nexus a month to I want some redundancy. Can I store some on your computer and then find another friend? And I can select it too. You create this, a security built around your knowledge of people, but there's security built into it without knowledge of these people as well. And it basically allows people to build up a reputation of being a good host of this data. And then they go into a smart contract together where you get paid a monthly fee for that. And that file system is going to be kind of integrated into the OS as well. So, when you're opening up a file in Nexus OS, you're not going to know if it's a decentralized file system, local, blah, blah, blah. That's all abstracted away from you. You just open up a file, right? It may take a little longer to open up a file if you don't have a local cache and you have to remotely grab it. It might, maybe not a spinning rainbow of death. We'll have to find out. Hopefully we don't have a death wheel. but you'll basically be able to, and so, it's really cool. It's really, I'm really excited about how it's all formed together.
So the file API is coming next.
Yeah, and this file system is like the first step towards a satellite file system, because the satellites are going to be, that is the incentive. Because when we came, and I might as well give everybody a little update on that. We purchased our first satellite. We're going to do it with Vector. Our original plan was we were actually going to help them on development of their Galactic Sky, which was basically using system virtual machines, where you can load up software on these satellites and you can rent them like it's a cloud, right? Which is a notable idea, but their architecture is sort of flawed. And now that we're deeper in it and we see everything that happened with Vector, it was a blessing in disguise, because Galactic Sky, we did have a strong relationship with utilizing Galactic Sky, but architecturally it would have a lot of challenges, and monetizing that would be very difficult for them too. So that has kind of adjusted. Right? It really came to, when we answered the question, is why the fuck would I want to put up a satellite? Like, yeah, it's cool, satellite communication, but why? What is in it to bring value into my life? Why is a satellite all of a sudden going to make my life better, right? And it really came down to the security properties of it, right? You don't want to really do you don't want to do on-board computation, right? If you're in orbit, you don't want to be computing stuff. It's like these satellite mining stuff, like just don't fall. This is a terrible idea, right? It just, you don't want to process on the satellite if you don't have to. You want it, we're going to have to do cryptographic processing and checksums and all of that, because you're flying through a giant radiation field, okay? So radiation comes in forms of beta particles, which are just electrons floating around. So with the way a transistor works, you have I'm thinking of a MOSFET. It's a base collector emitter, right? And so what ends up happening, if it's an N channel or an N channel transistor, it basically is a higher voltage going onto your gate, right? that's going to cause that switch to open, right? Now, if you're flying through space and you have all these electrons floating around and the electrons start collecting in these transistors, what's going to happen? Well, you may not have an actual circuit turning that transistor on, but all that electron cloud will start to build up a voltage collecting in the gate, and then it'll flip the bit, right? Which means a 0 or a 1. It should be a 0 is now a 1. Like your bits will start flipping, which is just, it breaks tons of things. So you have to have 2 processors and you have to have multiple sticks of RAM, because data does become corrupted on the satellite. So that's, the blockchain is really important for bridging that. But so the value proposition with these satellites is, well, I should be able to run a business, right? It's putting a satellite up is something that I can actually monetize. I can return on my investment. It shouldn't just be something that people do out of the goodness of their heart, because not everybody has good. I mean, deep down, everybody does. They're just too clouded with other stuff. They're driven by their self-interest. So just like the bee, right? The bumblebee, it flies around. He's pollinating flowers, unknowing, because he's seeking honey. He's just trying to get honey, trying to get nectar. He does all of that, but yet unknowingly they pollinate the entire field, right? But in the same type of concept, you are able to have the self-interest that's driving these people, right? They're driven for having, more ROI on their satellites that's going to produce this value for the rest of the system. So these satellites we're creating an actual routing system, which is actually really, I wish I could tell you more details on it, but it's a stateless routing system. So with routers as they stand right now, you have these routing tables, right? You have this big table, which is like, this address goes there, this one goes there. What you're basically doing is you're mapping this hardware address to a GPS locator, right? That's what an IP address is basically doing, is something the computer can understand in computer language mapped to a physical location. And that's basically what your IP address is. Now, it needs that to go through these routes. So you have this thing called BGP, which is Border Gate Protocol, and you have these massive routing tables, right? Because all these different entries, and a router is just kind of like a tree. Go right, go left, go right. Hey, do I need to go that direction? I'm going to go that direction. So it requires a lot of state. State just means data. You have to have a lot of information in order to route. This routing system that we're designing is actually stateless. So I don't have to know about anyone else on the network. I don't have to have any routing tables. I only need to know where I am and where my neighbors are. That's it. That's it. I don't have to update routing tables. I don't have to exchange data. You don't have to push across the network. Like all of this cumbersome stuff with managing state, gone, stateless, right? And that is, if any of you are software engineers, that's really powerful, because managing state is cumbersome. And when we're dealing with limited computing cycles on satellites, you want to manage the least amount of state as possible. So this routing system is actually materialized far beyond what I would have expected, which is really, really incredible. So, I mean, we've made really amazing strides on that. Like, I mean, these satellites came from being like here as far as attainability to like here. I mean, it's just like way attainable now, like compared to where it was months ago even. I'm especially figuring out the ISM frequencies and stuff like that. So the value proposition is, well, what is it that's better about a satellite, right? Well, it's physically isolated from Earth, right? I cannot physically access that satellite, right? So I can't run side channel attacks on it as effectively. And also I can't break in and steal the actual hardware, right? And that's one of the biggest security flaws, right? Humans. They are the biggest security flaw. Social engineering is far more effective than breaking cryptography, right? You're not going to break the cryptography, but you can trick someone into giving their password. And that happens all the time. So you have these secure facilities and yada, yada. They can still be breached, or even things that are air gapped, right? Like, I mean, there was a virus that went around that was attacking the centrifuges of nuclear missile silos that actually jumped an air gap. An air gap is where you literally, there's no physical connection to the internet in that network. It jumped an air gap by using flash drives and social engineering, and it got into all these nuclear missile silos and caused a centrifuge to spin fast and then destroy itself, right? It's big problems, right? Even with air gap networks and all of that. So physical isolation is really, really important. I'm going to pay an extra premium. I'm going to pay more per byte or per gigabyte than I would for a ground-based file system to store it on that satellite, because you have major security properties of it, and you have another layer of redundancy too. Because if anything does happen on the ground, let's say people are afraid of these solar flares. I've heard those solar flare theories. Oh, we're going to lose all computers, everything's going to. Yes and no. I mean, you maybe would lose some amount of satellites, but satellites are already radiation hardened, right? Especially the geosynchronous. So it's like, it'll burn some of them, but like not all of them. But I mean, you're still going to have quite a large amount of satellites. But I mean, some of the ground stuff could get a little bit messed up, right? So this gives us another layer of redundancy, but also our intercontinental routing system. And by applying this game theory into all of it, right? And this is what I've said to people before, the blockchain, like, we're developers, right? We're engineers. We develop software, open source, but we don't build the blockchain. Some people have said, like, well, how are you going to get funding with the price? And it's like, okay, well, do we have to get funding to like secure the network? No, we don't. We don't, like, Paul and me, like, don't buy miners. And like, I mean, that's actually the opposite effect of what you want. We don't buy all the miners to mine and build the blockchain, right? Because it's not effective. The security comes from the game theory because there's an incentive to build the blockchain, right? There's a certain amount of Nexus produced every block, and that Nexus is worth a certain amount of monetary value. So the blockchain builds itself. Now, this is the game theory that our architecture now is harnessing in a really beautiful way, so that the satellite constellation will build itself, right? We're developing the initial open source software, like the operating system, the routing system, all this other stuff. And we're kind of putting together, or at least I am with some different people, a group of very well-rounded engineers to be helping with this initial architectural development, implementation, and stuff like that. So Nexus OS is going to become a collective effort. It's going to become a collective open source operating system that a lot of people help contribute to. And it built in will have all this gamification built in, right? Where I could fire up Nexus OS on my new computer and it says, okay, you have a terabyte hard drive. Are you going to use it all? You say, no, I mean, I'll sell 800 gigs of that for now until I run out of space, and you can even set it too, where it's like, okay, well, if I run out of disk space and I say I want to sell the rest of my hard drive, but I fill up my empty space, you can just start eating into that other space and you just start losing hosting fees, right? So it'll be a pretty seamless process, and it'll allow you to actually capture the value your computer is producing 24/7. Right now, we don't capture all of that value. We don't capture what it's capable of producing for us, right? And this is part of our whole, not everybody has money, but everybody has time philosophy. And this is a way that I think this really shines, because not everybody has money, but everyone has time. So everyone has the equal opportunity to be running their computers, to be developing their hardware and things like that in order to start selling. And anyone in any third world country will be able to start selling some disk space. And hell, that 5 Nexus a month, 10 Nexus a month, however much it ends up going for, could be the difference between having food or not for them, and that's one of the things that was really important when I found cryptocurrency is I realized this is a way to not only reset the economic system, but it's a way to provide opportunity for everyone to receive the value that they create. Right now, I mean, with all this scamdemic crap and everything, I mean, they're trying to create this separation between the lower class and the middle class, because that's slavery, right? If there's middle class, then you don't have as effective a enslavement society, right? But they're trying to create this disparity between the two. Now, this is going to counter that, right? Because people are going to start being able to earn money. Then they earn a little bit of money from that money, and then they invest in putting a new computer up, and then they start running multiple computers and they're racking it in, and then they decide to invest in a satellite, and it creates all these new opportunities for people that weren't previously there, and it gives them the ability to actually own it, right? I mean, when ISPs are horrible. I can't wait till they go out of business. It's going to be great, because I swear, I'm looking, it's just, the internet is something that should be free, right? I mean, I'm already bombarded with advertisements, all this garbage, right? The user should not have to pay to access it. You should only pay to utilize it for your own monetary benefit, AKA creating a service. I should pay for running my service because I'm gaining some sort of monetary value in exchange for that. But the access to the internet should be free, right? As long as you help provide that access for other people. So that's where these mesh network antennas come in too, is you'll basically be routing for other people, and all these satellites up there will route for other people too. And the way that we're going to do the routing system too, there will be a bit of state required about your local nodes, the nodes that you most recently talked to. Now, these are all going to be in kind of a ring, so they're not going to really be dynamic with one another. They're going to be pretty fixed, you know, satellite to satellite. So when your node goes up, you'll have a pretty good idea of your 16 closest neighbors, right? Your 16 closest satellites. So if Bob over here starts sending lots of packets to me, right, but then he never forwards any packets I send to him, over time, Bob's just going to start getting ignored, right? And Bob will degrade into just like lone satellite over here. And it's going to kind of show, you know, it's going to create this incentive for people to route for one another, you know, including multicast traffic, which right now ISPs kind of do, kind of don't. You know, they have this kind of like unwritten law that I'll route for you if you route for me, but I'm only going to route you unicast traffic. I'm not going to route multicast and yada, 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 right? So that all kind of ties together. So we've been continually making progress. We have not started implementation of Nexus OS yet. It's still in architectural designing phases. So it's getting pretty close though. I mean, we still have hardware and other stuff to figure out, you know, like specific frequencies and, you know, I mean, phased array antenna design and stuff like that. But it's 3 years ago, it was a dream in a way. Now, I mean, we've always had the intention of doing it, but I don't think we had a good idea of how to do it. It was kind of an idea that my dad and me shot around. And then when Galactic Sky came around, and they were working on this Galactic Sky, we became very valuable for them as a use case, right? And he started noticing that people got really interested, and he said, well, we're going to store blockchain on this too, because it was starting to grow. So that's where this whole satellite thing kind of emerged from, is Galactic Sky. And then with Galactic Sky, it's like, okay, well, this is still centralized. We need it decentralized. So, you know, that's when we hired Phil to figure out all the telemetry systems and how to do that. Phil ended up not working out, not making as much progress as we would have hoped, but we now have gotten to an understanding where like this whole, you know, this satellites, I mean, it's vague what we're going to do with them. This vague values like has become very solid and very, very achievable. And all of these hurdles that we've had, frequency licensing, gamification, architecture, physical hardware, I mean, all these, they're gone. They're gone. And the last one was actually the routing, because I was always like, oh man, we have to design a completely new routing system. What that means is we're developing a new internet protocol. IP does not exist on Nexus anymore. We don't do IP. IP's old, throwing it away in the trash can. We're not doing IP version 6. That's throwing in the trash can too. We're developing a totally new routing system. But the beauty of it is there's not a whole lot to develop on this routing system. It's that elegantly designed. And it's using like GPS coordinates and stuff like that. But I don't want to give too much away right now, because then it ruins the surprises. But yeah, that was the last like engineering and architectural hurdle to overcome. So now, I mean, like I said, it came from this, I don't want to say pie in the sky, but it was pretty, you know, it's not like it was unachievable, but to the extent to what we wanted to see, the results of it, like the implementation was very difficult and architecture was very difficult. It wasn't just money. It was all these other hurdles that had to be overcome. That is down here where it's, I mean, it feels more and more and more and more achievable every day within a very short period of time, like the development cycles and all of that. I mean, it's not going to happen tritium soon, right? But it's definitely like with Kendall. I mean, we've overcome these hurdles, and now it's kind of just, you know, knocking out the pieces that are required along that path. But the path is charted, and it's very, very clear to us now. The value proposition of the satellites, the gamification, then even the technical architectures. So that's been something that's been really exciting too. Especially, I know a lot of you guys have been really excited about the satellite concepts as well. And we're starting to see more and more of a need for it with rising censorship and everything like that. And ISPs are just getting horrible. I mean, they're just becoming so terrible these days. So it's time. And yeah, it's happening, which is really cool. I mean, even with the limited resources, we've still been able to make pretty significant progress on that. So yeah, I think that's about it. Paul, you can unmute yourself now.
Cool, thanks. No, it's good. I wasn't expecting us to segue into that today, but it's good to give people an update on where you've been at. It's a long Zoom today.
I know, man. I mean, this is good. This is super interactive. Like, I loved it. It was everybody getting pieces and everything. You guys have been awesome.
Colin, you're not at all excited about that. Am I getting feedback? I heard weird noises.
I think he might just be a little bit excited.
Just a little.
Sarcasm noted.
Face of excitement. Yeah, man. So I'm really excited because it's kind of like listening to music to me, right? Like the algorithms, it's just like hearing a beautiful song to me. It's just like, oh my gosh, that's just so beautiful. It's just how all of these things have just come together. It's just really beautiful. And this is what I'm excited. I mean, it's just, yeah. I mean, yeah. And I'm grateful for all you guys too, for sticking it with us. And like, we're doing really good, and everything's just getting better and better every day. And yeah. So thank you, everybody, too.
All right, on that note, I think we'll wrap up this over 2 hour Zoom. And
how long it was, man? Damn. And we only lost 5 people. You guys, some serious like attention spans, man. Like usually, I mean, this one was a pretty hardcore Zoom. You guys did rock and roll. Bad ass.
They might all be
Awesome.
Something, Ryan?
Oh, I was just saying, yeah, it was great. I missed some of it because I'm at work, but I'm going to re-listen to that. Thanks for putting all the time in with this one.
Yeah. Absolutely.
I love it, listening to it at work. Brilliant.
Yeah. Dude, I mean, it's how many people are just like, oh, I do mostly Nexus in my day job. Like, it's been that way for so long. They're like, like me and everyone. They're like, oh wait, I have to go like talk to my boss for my day job. Like, I'll be back in a couple minutes. Why is the world not working? I don't know. I think they're working on Nexus.
Yeah.
You need to do your job.
Facts.
Yeah.
Hey, Paul, Colin touched on it, but your peer-to-peer there was an encrypted connection, right?
Yeah.
Oh, that's pretty
Yeah,
cool.
so that,
Yeah.
So
It's
it wasn't just a connection; it was a secure connection.
a peer-to-peer encrypted and authenticated connection, which it doesn't exist anywhere. You can't authenticate. The only way you can authenticate a connection, especially with SSL, is to use a certificate authority, which means if I wanted to communicate with Paul in a completely authenticated way based on conventional protocols, we would both have to have our own security certificates registered to verify that we are who we say we are. And then I'd have to check that registration database, which is, again, their centralized database, every time we talk, right? To make sure that now that also could get polluted, that could get corrupted, that could get hacked. I mean, there's so many things that are wrong with it. Plus security authorities charge you and blah, 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 blah. This gives you better functionality, better security, better performance all across the board, and you don't need anybody. You just use and your peer.
yeah, so the actual connection itself is using SSL. Well, I've chosen to use SSL. You don't need to, but with my nodes they are. So that's using self-signed certificates to at least establish an encrypted connection. But then, yeah, we're doing the verification of who each person is by signing an initial message and checking the signature chains and so on and so forth. So yeah, it's
add to that the certificates. I don't know if it's implemented in this current implementation of the P2P API, but we have a cert, public key hash, in the crypto object register that stands for certificate. So if you want to have certificate authority like authentication, right now we're doing the authentication not necessarily with the TLS handshake, but we're authenticating the actual connection based off of another signature on top of the SSL, right? But in order to authenticate like a certificate authority, all you have to do is hash that security certificate and check the crypto object register. So you can actually do fully authenticated TLS with the power of certificates, with self-signed certificates with this technology, right? And we built it to be able to handle it. Don't know.
Yes, not doing it yet, but we can add it.
Yeah, it's all in there. So I mean, it's some of these things are just like it's all there, just plug in, things like that. So that's just one of those things you just got to plug it in, just like the SSL. We just had to plug that in. But yeah,
Right, I'm losing my voice because I've been talking too much. So
well, it's a nice change. I was like, oh my gosh, Jules, I don't have to talk this whole time. Like, it's been like a year and a half. It's just like, I'm just like, look at you guys. You guys like you giving demos. It's so cool. I love seeing it. It's great. You guys are awesome.
yep.
All right.
All right.
Anybody else need anything, or I think we're good.
No, I think that's everything.
Like everybody's messaging me privately. Did I like make it so you can't?
Yeah, you can't do a group messaging.
I know why I did that. Yeah. Oh. I won't say anything about that. Never mind. Okay. I was gonna say something, but I don't think I should say it. It's not anything bad or anything. Slack has been much more peaceful, I'll say, because there's a lot of nice anti-troll technology. And that's all I'll say about that. And that is why I think I disabled for group messages because of the potential for trolling. So sorry about that, guys. Maybe we'll enable it next time.
Sounds good.
All right. I guess without further ado, I bid you all. I think we'll do once a month. I mean, just let us know when you guys are itching for a Zoom. I think we'll just kind of play it by ear that way. We'll try to keep it on like a monthly structure, but I think this one, people just were like, hey, when's the Zoom? Okay, we'll do a Zoom. So yeah, just demand us to do a Zoom when you guys want another one, and we'll try to keep them like monthly. But yeah, we'll see how it all goes. All right.
See you later, everyone.
Peace and love, everybody.